Sleep is something that all of us experience, but few fully understand. In my opinion, it can even tend to be one of the most overlooked parts of our health. In this video, I'm going to give you a bit of an overview of what happens when we sleep, and hopefully by the end, you'll have some newfound respect for something that consumes about 1/3 of our life. Sleep is marked by a state of pronounced alterations of consciousness and wakefulness that is brought about by physiological changes in the body. What helps to regulate your sleep pattern is exposure to light. Historically, this was, of course, dictated by exposure to sunlight, since for much of human history, that was our only source of light. However, exposure to artificial lighting, like from a lamp or a computer screen or cell phone, can also influence periods of wakefulness or even delay onset of sleep. The way this happens is that when light enters our eyes, it goes through our brains towards the occipital lobe in the back of our head. Along the journey to the occipital lobe, these optic neural pathways go through the thalamus. The thalamus is basically like the meeting point of many of the sensory systems in our body. Exposure to light activates or deactivates a part of the thalamus called the suprachiasmatic nucleus, or SCN for short. The SCN is located right next to the hypothalamus, which helps regulate our brain and body's physiological functioning. In many ways, you can think of the SCN as being like our own internal clock. The hypothalamus is located right next to the pituitary gland, which is considered the master gland of the endocrine system. The endocrine system regulates the release of hormones throughout the body. Sleep is brought about by the release of hormones from the pituitary gland and neurotransmitters from the hypothalamus that help trigger the onset of sleep. Some of the two most important chemicals that help trigger the onset of sleep are melatonin and adenosine. In fact, caffeine is an antagonist of adenosine. So basically, when you drink caffeine, it blocks the effect of adenosine, which means that it delays the onset of sleep. It's worth noting that sleep is a really complex physiological function. It can be influenced and interrupted by a vast number of different things. Sleep is primarily important for two main reasons: the adaptive function of sleep and the cognitive function of sleep. The adaptive function focuses mostly on the biological benefits of sleep. When you're awake, your body is putting stress on itself. Much of the maintenance work that your body needs to repair itself can't be done during the day because you're still active. When you sleep, your body can help repair itself. In fact, much of the immune system functioning and body growth and repair happen when we're sleeping. This is one of the reasons why when you're sick or injured, a doctor will always recommend that you get plenty of rest. They know that when you sleep, your body's healing itself. The cognitive function of sleep deals more with mood and memory. Sleep is critical for our ability to function psychologically, and people that tend to be sleep deprived will have a whole host of both psychological and medical issues. You can see a list of some of those issues here. When it comes to how we study sleep, it's important to talk about how it's done. One of the main ways we're able to study how our brain functions while we sleep is through a technique called electroencephalography, or EEG for short. This is something that I talked about before. It involves a person wearing a net of electrodes over their head that measures their brain waves. We have found that brain waves tend to change between when we're awake and alert to when we're sleeping and during various stages of that sleep. Now, brain waves are a measurement of the electrical activity within your brain. There are some terms that we use to talk about these different patterns. For the sake of this class, you can think of the amplitude of a wave as being kind of similar to the height of the wave. So this wave would be considered a higher amplitude wave than this one. The distance from one wave to the other is known as the wavelength. The number of waves present within a specific distance is known as the frequency. So this wave has a higher frequency than this wave because there's more individual waves present in the first pattern than in the second one. Generally speaking, higher amplitude waves are stronger than lower amplitude waves, and higher frequency waves are faster than lower frequency waves. When we go from being awake and alert with high states of consciousness, we have a brainwave pattern that is lower amplitude and higher frequency. As we go into deeper stages of sleep, we move more and more into a brainwave pattern that is higher amplitude and lower frequency. We have different names for these patterns, and they're present during certain stages of sleep. There are 4 main stages of sleep. They are divided up into what is known as non-rapid eye movement sleep, or NREM, and rapid eye movement sleep, or REM. NREM has 3 stages, and REM only has 1. So we can look at these stages in terms of the brain waves that are present. When we're awake, we have beta wave patterns that are very low amplitude and very high frequency. As we start to drift off to sleep, we have alpha patterns for stage 1, which then go to theta wave patterns in stage 2, delta waves in stage 3, and as we go into REM sleep, we start to gravitate more towards the alpha patterns that we experience while we're awake. Again, the general tendency is that the more active and alert you are, the more the brain waves are higher frequency and lower amplitude. Deeper stages of sleep that involve lesser states of consciousness involve brain waves that are higher amplitude and lower frequency. Besides the difference in brain waves, the separate stages of sleep also have some unique features that distinguish them from one another. Let's start by talking about stage 1, or NREM 1. Stage 1 is a transitionary stage of sleep. Frequently, if someone is in stage 1 and are awakened, they may not even have realized that they were sleeping in the first place. This is the reason why I call this stage the "I'm just resting my eyes" stage. You all know what I'm talking about. Like when you get caught sleeping, somebody wakes you up and you say, I wasn't sleeping, I was just resting my eyes. Typically, a person doesn't spend very much time in stage 1 sleep. Stage 2 sleep, by comparison, accounts for roughly half of your time sleeping. The initial muscle relaxation and lowering of body temperature that starts in stage 1 continues. Our brains start to exhibit theta brainwave patterns. If you wake somebody up that is in stage 2 sleep, they'll definitely know that they were sleeping, unlike a person in stage 1. But they will also not be groggy or tired. Generally, people in this stage are a little quicker to react and have more conscious awareness. Besides the theta brainwave patterns, the electrical activity in your brain does something else a little different in stage 2 sleep. You start to experience periods of sudden high-frequency waves called sleep spindles, and sudden bursts of very high-amplitude waves called K-complexes. Because stage 2 sleep involves increased sensory awareness, I like to think of it as being the middle ground between deeper stages of sleep, where it's more difficult to be wakened, and being fully awake. After all, think about this from an evolutionary standpoint. When you're sleeping, you're kind of vulnerable. This is the reason why a lot of animals don't sleep for extended periods like humans do, because they'd be easy prey for larger animals. Now, I don't think I'm going to be preyed on at night while I'm sleeping, at least I hope not. I mean, I trust my wife and everything, but what if there's a fire or someone breaks into my house? I still need to be able to wake up if something happens and to respond quickly if I need to. Stage 2 sleep allows us to do this while still being asleep. Stage 3 sleep is the last stage of non-rapid eye movement sleep. Sometimes you hear stage 3 called slow wave sleep or deep sleep. If you ever were awakened in the middle of the night and were super groggy and disoriented, you were likely in stage 3 sleep. Sensory awareness is at its lowest in this stage. It's also believed that this stage is the one where much of the growth and repair that is needed in your body is done. The final stage of sleep is rapid eye movement sleep, or REM. Although this is technically stage 4 sleep, it's almost never called stage 4. I'm sure almost everyone knows that REM is the stage where you dream. For this reason, REM is often called paradoxical sleep. What that means is that although you are asleep, your brain is actually exhibiting brainwaves that look like you're awake. A part of your brain called the pons is particularly active during this time, and it plays a critical role in getting the larger muscles of your arms and legs to be paralyzed. This is something that a lot of people are surprised to hear. When you dream, the larger muscles of your extremities are mostly paralyzed to prevent you from acting out on your dreams. Now, this isn't always the case. Children, for example, can sometimes occasionally not have this be present. And some people have a disorder called REM behavior disorder where that mechanism simply doesn't exist. Also, keep in mind that although it isn't too common, a person can go from REM sleep into stage 2 or stage 1 sleep or even wake up. Sometimes this can happen so quickly that it feels like you're acting out a dream. Another misconception many people have is that because they don't remember their dreams, they say they don't have them. Everyone dreams, but it is very common with adolescents and adults to not remember them. I've heard that a good way to show that you dream if you don't remember them is to drink 3 glasses of water before you go to bed. Because you're drinking all that liquid, you're going to be waking up throughout the night to go to the bathroom, and because you're waking up more often, you're actually going to remember the dreams that you're having. Now, I've never tried this, so if you do try it, leave a comment below because I'd kind of like to hear how it goes. One thing that is really interesting about our sleep schedule is that we don't necessarily go from one stage to the next like many people would expect. In fact, you can actually bounce around quite a bit. What you see here is a hypnogram. It's a graph that shows the stages of sleep a person is in during various parts of their sleep cycle. There are a couple things to consider here. The first is that people generally go into stage 3 sleep within the first half of their sleep. So if a person slept for 8 hours, they're probably going to be getting stage 3 out of the way in the first 3 or 4 hours. You can also see that we tend to move around the sleep stages in a cycle that repeats about roughly every 90 minutes. Just like how we have stage 3 in the first half of our sleep, we generally experience more and longer periods of REM sleep in the second half. The way I like to think of it is that stage 3 is critically important for physical health, so your body tries to get it out of the way first. REM is important for cognitive functioning, so it tends to happen closer to when we wake up. The other thing I wanted to point out is that the average person actually wakes up during the night. You probably don't realize this because it can often be for very short periods of time and you aren't really fully consciously aware during those moments. But the average person is awake 2 or 3 times a night. Now, of course, this is how sleep generally occurs. There are a whole host of issues that interfere with the sleep pattern, and I'm going to be discussing those issues in another video on sleep disorders, so make sure you check that out. Thanks for watching, everybody.